Hello everyone, welcome back to this lecture series on the mechanics. This is Dr. Rahul Srivastav, Assistant Professor, Department of Physics, Bhopal School of Social Sciences, Bhopal. As we have started this lecture series previously, and this is the second lecture of this particular series on the mechanics, which is dedicated to the scalars and vectors. So these are the scalar vector quantities which we covered in this particular lecture series. So let me start this lecture with the definitions of physical quantities. The physical quantities are the numbers or the numerical values followed by the unit which defines the physical property or the condition of any material. These are the quantified values or the numerical numbers which defines the actual condition and actual properties of material. So these can be expressed as the numerical value followed by the unit. Let me describe you with the help of an example. That is, the mass of a particular object is 10 kg, and this 10 kg is defining the physical quantity or the physical property and condition of any material, where 10 is the numerical value which we are discussing, followed by the unit. This unit actually describes the actual physical property or physical unit of any object or material. In the case of this 10 kg, this is defining the mass. So the mass of any body is 10 kg, which where 10 is the numerical number which is having some numerical quantity, numerical value, followed by the unit. If it is kg or gram or some other mass units, then this is the physical quantity we are measuring in the mass, followed by the temperature, degree Celsius, degree Kelvin. So it is let 35 degrees Celsius, which is defining the value 35, and degree Celsius means it is a temperature, kg it is a mass, and some other also. So these all are comes under the category of physical quantities. So the measurement of these physical quantities depending on two things. First one is the magnitude, and that is the sufficient value. So magnitude is defined with the numerical number followed by the unit. For some physical quantities, there is only and only magnitude is sufficient for them, and we can easily understand the value or the particular amount by the magnitude itself. But for some other quantities, along with the magnitude, the direction is also required. Direction defines the particular value in this particular situation, position, and so on. So I will describe you detail both the things. So on the basis of these two conditions, we are having two types of physical quantities. First one is the scalars or the scalar quantities, and the second one is the vector or vector quantities. So let me start with the first question, that is, what is scalar or scalar quantities. So scalar quantities are those quantities which requires only and only magnitude. That is sufficient to explain them, that is sufficient to define these that is sufficient to define these physical quantities or magnitude of these quantities. For example, this car is showing in the image, and the length of this particular car, that is from this place to that place, is 4.5 meter. There is no need to describe or define the direction. At any direction, this car will remain with the same length. So we can say that this length is a physical quantity, and this is a scalar quantity, because this is require only and only magnitude, that is 4.5 meter. Second, we can calculate the length, width also. Let me take an example, something around 2 meter width of it, and height also something around 2.5 meter. So these are the sufficient quantities which are defining the whole phenomena or the whole dimension or volume of this particular car. So we can say that length is a physical quantity which is scalar quantities, only magnitude is sufficient. Followed by another one, the mass of this gold bar. The gold bar, we are seeing it. It is having some mass of 1 kg. That 1 kg is sufficient, whether it is in the east direction, whether in the west, north, south, and all dimension, in all direction, this gold bar will have same mass 1 kg. So that is sufficient. That is sufficient for describing this physical quantity. So the weight or mass all comes under the physical quantity as scalar quantities. Another example, temperature 36.8 degrees Celsius, dimensionless. It can count, it can measure at any dimension. The magnitude is sufficient, which is the physical quantity temperature, and magnitude is 36.8 degrees Celsius, and that is the sufficient value. This 36.8 is a value we are having, and this is the unit degree Celsius. So, these two together will make the magnitude, and that is sufficient for the scalar quantities. Now, enough for the scalar, we are going for the vectors. So, what are the vectors, or what is the vector, or what are the vector quantities? Vector quantities are those quantities which requires magnitude, that is for sure, but along with magnitude they also requiring direction. So, a vector is a physical quantity that has magnitude and a direction. So, direction is must there. So, let me give you some examples starting with the position. So, the position of California from North Carolina, So, the position of California from North Carolina is around 3600 kilometer in west direction. So, the direction is must there. If we are taking it in the east, so this position will change. We will not find the California, we will find some other country there. So, the direction is must. So, we can say that the Carolina, from Carolina. So, we are considering a position of California from Carolina. So, the reference point we are taking here, and we are considering the position here. So, it is in the west. If we make the direction east, west, north, south. So, this is showing the west direction. Okay. So, west direction in this particular, it is having something around 3600 kilometer distance in west direction. So, the position we are taking, or it is a vector quantity which is requiring magnitude as well as direction. Another example, the displacement from USA to China is around 11,600 kilometer. So, this is the magnitude, value, unit, followed by the direction in east. Imagine if we are going in the west, we will not go to the China, we will land it somewhere else. So, USA and China, if we are taking USA as a reference point, so displacement from USA to China is around 11,600 kilometer in east direction. So, these are the examples of scalar and vector quantities. So, the representation of vectors or vector quantities we generally take as an particular equation. So, if the denotation or symbolically we represent it as A, B and arrow on it, this arrow defining the direction. So, what is A and B? This A is a starting point, or we can say it as a tail, then after it is going towards the B. So, the position is changing from A to B, and it is going from A to B. So, we are writing it as AB, and this arrow is defining the direction. So, this direction we calculating, this tail is, the straight line is drawn something here in this place, and the angle which is creating in this particular region. This is defining the direction. So, the direction of AB is calculating by the theta, because it is an angular momentum or angular rotation. So, that it is calculated as theta. So, this theta is defining the particular direction or angle. So, generally we take it as parallel lines, or we can say that as perpendicular lines. It is somewhere like this. If graphically we want to understand, see, east, west, north and south. Now, if I am drawing a straight line here, so this is the north, this is the south, this is the east and this is the west. So, it is, this B is something around at northeast, we can say that. So, angle is must. We are not specifically going in the perpendicular lines always, something like we are always not going in the east direction, we are not always going in the west direction, or followed by north south anywhere. We are going in the zone or in the particular coordinates following by the two dimension like north east, northwest. So, this angle is must. If it is 90 degree, then it is sure that it is going in the east or in the west, but it is having some angle something around like 45 degree. So, this is defining the particular angle, and this angle defines the directions. So, this is what the representation of vectors are there. This arrow particularly showing the direction, and this direction mathematically we are defining with this theta and this magnitude AB. So, this is what symbolically we are representing vectors. Now, at last we have to compare these scalars and vector quantities. So, the scalar quantities requiring only and only magnitude, that is sufficient, means value plus unit, these two are sufficient. Example, length, mass, temperature, time. Time is also a scalar, like something, if the time is happening 11:30 AM. So, that is same, if it is happening in the east direction will remain the same, will happening in the west or in somewhere any direction will remain the same. So, time is also an example of scalar quantities. Vector quantities always require magnitude along with direction is must there. So, the scalar quantities are not requiring any direction, but vectors are always required to explain a direction. Examples, position from A to B. In previous slide we have discussed A to B, of whether this B is in east direction or in the west or somewhere direction. So, the direction is must, we have to define it. Displacement also, the displacement is the smallest path between two objects. So, in which direction the displacement is also requiring for it. So, these are the some examples of scalar and vector quantities. So, this particular lecture series is always dedicated to the mechanics, and we will further go detailed topics of the mechanics in the following lectures. So, for today it is sufficient for this scalar and vector quantities. This is Dr. Rahul Srivastava. Thank you for your kind attention. Have a nice day.